Domain and range of a graph. All right, so previously we had talked about how domain, those were the x values of the graph of a function. Those are the allowed inputs. And we talked about how range, those were the allowed outputs or y values, the possible y values. So when we're looking at a graph, the input is the x value, the output is the y value. We can find domain and range based upon a graph. Let's look at a few graphs here and find the domain and range in interval notation. The only outlier here is going to be this very first graph, which we'll do in set notation. Because this is a discrete graph here, the values can be listed. For every other graph, there are infinitely many points, so we'll need to do intervals. So this first set of points, we have a few different coordinate points. This guy right up here is the coordinate point -5, 3. I'm just going to write this set of points. This point here is -5, 0. This is not a function. It fails the vertical line test, but it is a graph. This is the point -3, -2. This is the point 2, -2. And this is the point 5, 1. The domain is going to be all of the x values from this set of points, all of the x values. So we have -5, which we will only list once, -3, 2, and 5. The range are all the y values. So we have 3, 0, -2, -2, which we will list only once, and 1. So we have 3, 0, -2, and 1. And that is the domain and range of that graph. All right. Those are discrete points. There is a finite number of items in the domain and in the range. It gets different when we have actual graphs with lines, with solid sections here, because now there are infinitely many. There are infinitely many points. For these ones here, we're looking at extending this graph off the screen infinitely. And we're asking ourselves, what values will the x, for all the coordinate points that exist at all on this graph, what are the possible x values and what are the possible y values? For the domain, this thing extends off forever. So every single x value will get used eventually. This entire x-axis, at some point, you'll be able to find a y value that for an x value on this line. So boop, 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 boop. This really goes from -infinity to infinity, the domain does. Because all x values will eventually be covered. Let's see, whoops. There you go. For the y values, it's the same idea for this line here. They're going to go from -infinity all the way up to infinity for the range. And this is just true of lines. They have domain and range that is -infinity to infinity. That's a line thing. Let's look at something a little bit different though. I want you to keep in mind one thing that we talked about in the interval notation video. Closed circles, those mean the point is included, and we use brackets when we're talking about that in interval notation. This is included. Open circles means that the value is being excluded, or if it's on a graph, that the point doesn't actually exist. And we use in interval notation parentheses. This is excluded. So looking at this graph right here, I'm actually going to reduce down the size of these highlighters. Right. There's this point right here. This is the point -4, 4. This down here is the point 5, -2. All the points from here to here will have x values that range between -4 and 5, right? For instance, -1 is in the domain of this graph because if you look at -1, I can find a coordinate point. There is a coordinate point that has the x value -1. There is a coordinate point that has the x value -3 or -3 and -2.5. Any of those values ranging between -4 and 5 have a corresponding x point on the graph with that x value. So the domain, right? We include -4. We're including -4 because -4 does have a coordinate point. It exists with a coordinate point. We are including 5 because this point right here exists on the graph. So our domain is going to be from -4 to 5, including both endpoints. For the range, the y values, the highest y value on this graph is 4, right? It begins at 4. The lowest y value on this graph is down here at -2. There are no points that have a y value less than -2. And this is telling me these are the range of x values. For the range, it's the range of y values. So do we actually reach the y value 4? Is there a coordinate point with the y value 4? Yes, there's actually several. So we are including 4. And is there a coordinate point with the y value -2? Yes, there is. So we are including -2. Our range is going to go from -2 to 4. Let's look at this same graph, but with like a small, tiny, teeny, tiny difference. Instead of this point down here being included, it's being excluded, but the entire graph is the same except for that. Our domain is going to be mostly the same. The problem is no longer do we have a point with an x value of 5. 5 is no longer in the domain because there's no coordinate point with the x value 5. Where it was is now gone. So we are not including 5, but we will include -4. So our domain goes from -4 to 5, but we exclude 5. Now, on the range, you might think that the same thing happens, right? You might be like, okay, so we won't include -2. Of course, 4 will stay the same. Nothing has changed up there. But we're actually going to keep -2 because there are several points right here that all have the y value -2. I can pick a, go away. I can pick a point 3, -2. This one right there has the y value -2. So -2 is in the range because it's a possible y value. So my range begins at -2 and it goes to 4. It's actually identical to what it was last time. Identical. The only difference is that 5 is no longer in the domain. All right, just a few more examples. For this guy here, domain, the x values. We know that there's a coordinate point right here at -4, 4. So we know -4 is in the domain because there is a coordinate point with the x value -4. So we're including -4. But then something weird is happening because this arrow here indicates that the graph goes off the page, which means that we are covering x values forever, off to infinity. So our domain includes -4 and all the way up to infinity, who always gets a parenthesis. The y values, the range of possible y values. Down here, there are many points that have the y value -2, so we are including -2. And it goes all the way up to 4, and there are points with the y value 4. So our range is -2 to 4. For this graph over here, when you see these arrows going off the screen, that means that we're going to be hitting x values infinitely in this direction. And when you see an arrow off the screen, just assume it hits every x value going that way. So every x value this way, every x value this way, because we have an arrow going off the screen. You assume that this behavior continues forever. So the y values are also going to go off to positive infinity. We're going to catch all y values after 0 to infinity. So our domain, again, it covers this entire x-axis. Because this thing goes off screen, there will be a coordinate point for every single x value. It goes from -infinity to positive infinity. The range begins at 0, goes to infinity. We include 0. We include 0 because the point 0, 0 is on the graph, which means 0 is in the domain, 0 is in the range. So we include 0, and it goes to infinity. A few more examples here for this graph here. Similar to the above graph, the domain is going to cover everything for the exact same reasons as the graph we just did. So the domain is -infinity to infinity. The range. We have coordinate points with y values 2 and below, right? Anywhere, any y value above 2, you're not going to find on the graph. There is no coordinate point with y value 4 or y value 5. So it has to be values that are less than 2. We include 2 itself because we have this point here, -2, 2, which means that 2 has to be in the range. So we're including 2, and this goes down to -infinity. We have to be careful because there's a tendency when we see something like this to want to write 2, -infinity like this. It's really, really tempting to want to write that. But with intervals, it's always smallest to largest. So -infinity is a smaller number than 2. So really, this is the range for this guy is from -infinity to 2. For this last example, for the domain does start at -infinity. The graph goes off in this direction, so we can assume that. But it stops at -1. And there's an open circle at -1, which means -1 itself isn't in the domain. There are no coordinate points on this graph that have x values greater than -1. So all of these values are not in the domain because there are no coordinate points that have those x values. So the domain goes from -infinity to -1 and excludes -1. The range is going to be identically the range from before. So we hit every y value from 2 all the way down. So the range goes from negative infinity to 2, including 2. I think that's the last one, yeah. So the big idea here is really, what are the possible x values of coordinate points? What are the possible y values of coordinate points? And because we can't list them all out, there are infinitely many coordinate points on here with different x and y values. We have to write them as intervals instead. This takes a bit of practice. It's one of those things you're just going to have to kind of practice to get the hang of. But if you have questions, please email me. Domain, x values, range, y values. Practice, practice, practice. That's all I have to say on this video. Have a fantastic day. See you in another video.